So very welcome to all of the students. So today we will discuss some of the important topics that will cover the as portion of your soil mechanics, that is geotechnical engineering, which will be very essential for your interview kind of questions, or means for your competitive exam, whatever. So first, starting with as per moving with the syllabus, we will discuss about the compaction. So what is compaction? So compaction already we know. हम लोगों को पता है compaction क्या होता है. Compaction means it is to densify. Soil को हम कैसे densify करते हैं so that it can achieve increased shear strength, reduced compressibility, permeability and void ratio, and volume reduction also occurs due to the escape of air under short-term loading under constant water content. So this is the very basic thing of the compaction. So whenever it is been asked, so you can answer like that. Next, compaction test is done to determine. So ये हम लोग क्या निकालते हैं compaction test से. So first one is amount of compaction, that is nothing but density, dry density, that is MDD, maximum dry density, and another is optimum moisture content. So these are the two important things which actually evaluated out from the compaction. Next is how actually we perform the compaction test. So first is standard Proctor compaction, that is which is used for highways, embankment and canal banks. So in that case, the setup is the mold volume is 1 liter soil compacted in 3 layers. Each layer is given 25 number of blows. Hammer weight is 2.6 kg and height of fall is 31 centimeter. So because you already have done, so it is easily can be understood what exactly it is been said. So this was for standard Proctor compaction or lightweight compaction. Now in some cases this kind of compaction is not enough. We need a little more to be soil to get compacted. So in that case we go for heavy compaction, that is modified Proctor. So this is actually used for express highways and for runways. So in that case mold capacity remains same, but earlier cases we used to compact in 3 layers, but now it is increased into 5 layers. Each layer 25 hammer blows. It is also almost same, unlike light compaction. However, the hammer weight has increased, that is 4.9, and the height of fall is 45 centimeter. So this is how it goes on. Now the compactive effort. So what is compactive effort? Like the way we have discussed right now, that two kind of compaction type is there. One is standard and modified. So obviously in both the cases there will be some increased compactive effort we need to put in modified Proctor test. So what is the times? Actually it is always remember that 4.5 times of that of standard Proctor test. Now you see these are the typical curve, that is OMC versus maximum dry density. So you see here the curve 1 representing the standard Proctor test and the 2 is modified Proctor test. So what happens with the increased compactive effort, the curve always gets shifted to left hand side of the curve, that is with increased MDD and decreased OMC. Now with the if we talk about how the soil type, how it varies. So in that case we can see that clay soil has a high moisture holding capacity. So always it is in the right hand side, maximum right hand side of the graph, so which indicate that high OMC. However, if we just go from clay to the silt, then sand, then finally to the gravel, although gravel is not mentioned. So means from lower particle size, if we move to the higher particle size, then we can see a kind of shifting in the curves that happen, which resulting in a reduced OMC and increased MDD. So these are the formulas dry density in terms of percentage air voids, by which we can calculate the zero air void line and 100% saturation line. Now factors affecting compaction. So these are very important. फैक्टर्स व्हाट आर द फैक्टर्स, कौन से फैक्टर्स जो है वो कंपैक्शन के मतलब अफेक्ट करते हैं. फर्स्ट वन इज वाटर कंटेंट. So you see as the water content increases, so here you see as the water content increases, gamma D increases, reaches a maximum value, then decreases. From this graph it is clear. Then amount of compaction. So from this curve we can see जैसे जैसे compactive effort increase होते हैं, gamma D increases and OMC decreases. From 1 and 2 we can see na 1 is standard proctor modified, 2 is modified, so 2 is higher compactive effort. Next is type of soil. So type of soil here we have already discussed. However, they have mentioned that for pure sand they do not have a well defined OMC. So always remember that not all the soil can have a this kind of graph. So here is the example that pure sand, if we take the pure sand, then we cannot have a this kind of graph like it is first increase then decrease. So no, we cannot get like. Now we have two things. One is we got the OMC. Now we have a dry side of optimum and wet side of optimum. So depending upon this, many of the construction are being designed. So we will see. So soil compacted on the dry side of optimum, what will happen? Have more swelling and more shear strength. So when we take any of this water content from this here, this left hand range, so we will get it will have a more swelling. It will have a more swelling and more shear strength. Although it will give more shear strength, but it will have a more swelling. However, soil compacted on the weight of the optimum, if it is in the weight of the optimum, then it will give a low shear strength because water is more. However, it will give low swelling. So these are the things. Now placement water content. It is the water content that is used actually in the field for compaction. So placement water content means in laboratory after हम लोग टेस्ट करने के बाद जो भी MDD and OMC निकलते हैं वही सेम कोऑर्डिनेट सेम वैल्यू हम फील्ड में जाके प्लेस करते हैं, तो उसको हम बोलते हैं प्लेसमेंट वाटर कंटेंट. सो नाउ यू सी हम लोग किस जगह पे कौन सा हम यूज कर रहे हैं. सो जब हम पेवमेंट फ्लोर्स एंड द कोर ऑफ द अर्दन डम में कर रहे हैं, सो इन दैट केस द सॉइल shall be compacted weight of optimum. The soil shall be compacted weight of optimum to avoid large expansion and swelling pressure. So in the core of the dam, soil shall be compacted weight of the optimum to avoid large expansion and swelling pressure. So earlier we have said na that weight of the optimum has a low swelling. So we don't want the core of the earthen dam to get swell. So that's why we go for weight of the optimum. However, the outer shells means outer coverage of the earthen dam of the should be compacted in the dry of the optimum to have a more strength and less compressibility. So you always try to remember. Next is compaction equipment. So now we have all the things we have discussed कि compaction क्या होता है, standard proctor क्या है, modified क्या है, then dry side of optimum, wet side of optimum. Now we will see हम compaction कैसे करते हैं in field में. So there are different kind of techniques depending upon the soil characteristics, nature of the soil. So tempers हम कब use करते हैं, like compacting of the confined areas like trenches, behind the bridge, abutments, etc. Smooth wheeled rulers for granular soil to provide smooth surface at the end of day's work to quickly drain of rainwater. So ये हम use करते हैं granular soil to provide smooth surface at the end of the day's work to quickly drain of the water in WBM means water bound macadam. Next is pneumatic tire rollers. So pneumatic tire rollers. This is used for both cohesive and non-cohesive soil. Casing of the earthen dam. Now sheep foot rollers. Sheep foot rollers, it is purely for clays, that is cohesive soil. And finally is vibratory compactors. It is suitable for granular soils only. For sand, best method. Next is relative compaction. So this is the important terminology that we need to always find out. So it should the value should come always more than 90, actually 95 to 98. So what is exactly it is, ये हम लोगों को निकालना बहुत ही ज़रूरी है कि ड्राई डेंसिटी फील्ड में कितना दे रहा है और मैक्सिमम ड्राई डेंसिटी दैट ऑब्टेन इन द लेबोरेटरी. सो द सेम सॉइल पे हम लोग जानेंगे कि मतलब कितना रेशियो कितना आ रहा है एंड मल्टीप्लाइड बाय 100. सो इफ इट इज कमिंग मोर देन 0.95 then it is okay. Now proctor needle, plasticity needle. So by proctor needle also in the field we can find out the whether we have actually achieved the appropriate density or not. So this is how we can cover up the most important topic which are related to compaction. So now you can go by your own. There is objective type of question which will be very much helpful for you to understand further of the things. So here you see, so answer keys are there in the bottom. You can check yourself. Now moving to the next topic, that is permeability. So soil permeability. So soil permeability क्या होते हैं? जैसे सॉइल में बहुत सारे वॉइड्स होते हैं, माइक्रो वॉइड्स, मैक्रो वॉइड्स. सो थ्रू दैट वॉइड्स पानी, द property of the soil which allows passage of fluid through it, through the void spaces. So when the soil has a continuous voids, yes. So in gravel and sand we can see there are lots of voids are there. So permeability इन दोनों में बहुत ही ज़्यादा होते हैं. A soil is said to be highly permeable when K is greater than 10 to the power minus 1 centimeter per second. So you try to remember that permeability का unit क्या है, centimeter per second or mm per second. So this is the unit. Now soil is impermeable. Impermeable क्या होता है? Clay में impermeable होता है. अगर clay में हम पानी डालेंगे so clay में पानी निकलने में बहुत दिक्कत होता है और बहुत टाइम लेते हैं. But in gravel and sand में क्या होता है? Gravel and sand में you can test yourself. If you have sand in your hand, you just go and place some water in the sand and check कर सकते हो कि आप पानी मतलब जल्दी से सैंड से निकल जाते हैं. और ग्रेवल में तो और भी ज़्यादा निकल जाते हैं क्योंकि वो स्टोन्स वगैरह है, बहुत सारे वॉइड्स हैं. सैंड में ही बहुत जल्दी से निकल जाते हैं, लेकिन इन क्ले इट टेक टाइम, लॉट ऑफ टाइम. नेक्स्ट इज Darcy's law. So what is Darcy's law? Darcy's law is saying for flow through soil, that is velocity, discharge velocity is directly proportional to the hydraulic gradient. So what is hydraulic gradient? Hydraulic gradient is nothing but a loss of head divided by seepage length. So del H में क्या होता है? Del H loss of head. Loss of head means suppose water is flowing from a certain height to the another height. So due to the head loss, actually the water is flowing. So this is known as loss of head. And divided by seepage length means how much distance it has traveled. So V is equals to Ki. What is K? K is coefficient of permeability. This is the unit. So this is how the Darcy's formula is. Now when hydraulic gradient becomes 1, we can say that velocity, discharge velocity is equals to coefficient of permeability. Now type of the soil and approximate values of the permeability they have mentioned here. We can see gravel is the most high permeability, then sand. Sand means 10 to the minus 2. Like as we moving to the clay direction, it becomes smaller and smaller. 10 to the minus 6, that means it is smaller. 10 to the minus 2 is bigger. Now validity of the Darcy's law, you can see if it is there in your syllabus. Now seepage velocity and discharge velocity. So there is a relation, seepage velocity is equals to discharge velocity by porosity. So you can remember and you remember these things that seepage velocity always greater than the discharge velocity. Now coefficient of percolations, these things you can see. Next part coming, factors affecting the permeability, means on which factor actually the permeability depends. So this is the basic general formula of the permeability. So here you see K is proportional to d square gamma W by viscosity into C E cube by 1 plus E, where everything is mentioned here. D is grain size, mu is viscosity of percolating fluid, E is void ratio, C is shape constant depending on type of soil, shape of soil particle and packing, and gamma W unit weight of the percolating liquid. So here from that we can see size of the particle K is directly proportional to D square, that is D10 square. Next is for same void ratio, the soil with angular particles are less permeable than those with rounded particles. K is inversely proportional to the specific surface area. So if our particle shape is rounded, so in that rounded part always the permeability will be high, unlike angular particles. Next is void ratio. So void ratio, you should remember that it is directly proportional to the square of the void ratio. Next is properties of the percolating fluid. So in terms of viscosity, and you see it is inversely related to the viscosity. So means a soil with highly viscous, and here you see permeability increases with increase in the temperature due to the reduction of the viscosity. So you see these things are very interviewed, very popular kind of question. Now degree of saturation, permeability of partially saturated soil is considerably smaller than that of the fully saturated due to the presence of air. Now permeability हम कैसे निकालते हैं? So we have two types of main thing, that is for gravel we use constant head permeability test, for coarse grain soil and the formula is Q is equals to KIA. However, for variable head test we use this is used for fine sand and seals, and formula is K is equals to AL divided by capital AT log E H1 by H2. So these things are mentioned here. If you have done this test, you can understand. Next is for clays. For stiff clays, we can go for consolidation test. From consolidation data also, we can find out the permeability. Next, for other things are there. You can see, just have a look. Now permeability for stratified soil means जब हम layered soil की बात करते हैं, layered means the soil properties are not same. Like 1 meter is different layer, next 1 meter is other layer. Like that, we have a different kind of layered soil. So in that, when the flow parallel to the plane of stratification, so जब flow parallel होते हैं layer with the layer, so in that case the formula comes. You see this K1 is for each like we have a layer 1, so layer 1 permeability and layer 1 thickness. So we have this formula. However, for perpendicular we have this formula. So ultimately, only remember a thing, we can have KH is always greater than KV. That is permeability in the flow parallel to the plane of stratification is always greater than perpendicular to the stratification. So this is how we can see permeability probable type of questions, and the concept we have seen. Now some objective type of questions are there. So definitely you should see. These are very common questions. If you can cover, definitely you will get probable question in exam. Answer keys are there at the bottom. So okay. Now seepage analysis. Moving to seepage analysis. So seepage is also some important terminologies related to the seepage are there. That is flow net, flow line. So what is flow net? Combination of the flow lines and equipotential lines. So flow lines means what? Like path along which water particle travels, also called the streamline. So जिस line से water pass होते हैं, so उसको हम flow line बोल रहे हैं. Next is equipotential line. Line joining the point of equal total height. नेक्स्ट इज फ्लो पाथ, द स्पेस बिटवीन टू एडजेसेंट फ्लो लाइन्स, जो दो फ्लो लाइन के बीच में जो एडजेसेंट स्पेस होते हैं उसको हम फ्लो पाथ बोलते हैं, ऑल्सो कॉल्ड फ्लो चैनल्स. Next is field, the space between any two adjacent flow lines and adjacent equipotential lines. Next is characteristics of flow net. So flow net का characteristics क्या होते हैं? Only 2 points are very important. That is, flow lines and equipotential lines are orthogonal to each other. Orthogonal means perpendicular. The quantity of the seepage in each flow channel is same. Other thing also you can see, but two things are important. Now, what is the use of flow net? By using the flow net, what we can achieve? So we can find out the seepage loss. So हम सीपेज लॉस निकाल सकते हैं, सीपेज प्रेशर निकाल सकते हैं, अपलिफ्ट प्रेशर निकाल सकते हैं, एग्जिट ग्रेडियंट को भी निकाल सकते हैं. So these are the utility of the flow net. So these are the formulas. I don't think these things are there in your syllabus that much of depth. It will be asked. So these are some objective questions. So please you go through this and you try to find. Lastly, we will discuss about the geotechnical investigation. So before we go for any construction, our first job is to testing of the soil properties, so that it should not create any kind of hazard in the future. So there are so many tests that we need to perform. A geotechnical investigation will include surface exploration, subsurface exploration of a site. Sometimes geophysical methods are also used to obtain data about site. So here you see few things they have mentioned. First one is surface exploration, then subsurface exploration. So surface exploration means surface level means we go for testing at the very shallow depth. Next is subsurface exploration, and finally in some special cases we can go for geophysical methods. So geophysicals are a bit newly introduced, actually innovative kind. So in our general daily to daily practice it is not required, but most of the cases normal days में हम ये दोनों very important, जैसे surface exploration और subsurface हम लोगों को करना ही पड़ता है. So directly we can go. First is surface में हम कैसे निकालते हैं? So soil sampling. So soil sampling means soil को collect करना. So there are two types of way we can collect. One is disturbed sample and another is undisturbed sample. So disturbed में क्या होता है? जो collect करने के समय जो soil का properties है वो change होने के chances रहते हैं. That means it is almost changed. But in undisturbed we try to retain the soil property as it is, so that we can directly shift it to the laboratory and we can easily make into test and can say that in the whatever the actual field condition. But we have many tests in the laboratory like grain size distribution, Atterberg limit, compaction, specific gravity, and other many more things. So these tests actually need disturbed samples, water content. So these things actually need disturbed samples. However, other kind of parameters, if we find to evaluate out, then for that actually it need undisturbed sample. So what is for that? Like we want to know shear strength, unconfined compressive strength, settlement value, consolidation value, permeability value. So these are actually we have to find out by collecting the undisturbed sample only, because this actually resembles the actual field condition. But however, other things are required, only disturbed will be enough. Now soil sampler, हम लोग soil कैसे collect करते हैं? So soil collect करने के लिए ये सब equipments and machineries है. So first one is shovel. So shovel सबको पता है वो क्या होता है, वो मिट्टी को खोदने के लिए हम यूज करते हैं. Then making the trial pits, then hand machine driven auger means hand driven auger or machine driven auger. Next is continuous flight auger, split spoon sampler. Then is modified California sampler, Shelby tube sampler, piston samplers, then page barrel samplers. So these are the so many kind of sampling apparatus are there by which we can collect the or gather the sample. Next is in situ test. In situ means at site test. So at the field itself we are going for the test. So in that we do standard penetration test. So this is actually been done in the field itself. So standard penetration test. Next is dynamic cone penetration test. Next is cone penetration test, then piezo cone penetrometer probe, then seismic piezo cone penetrometer. So finally the flow penetrometer, helical probe test are also there. So out of them, this is the most important. You remember this thing, standard penetration test. Other two are also a bit important, but first one is very important. So by this actually we collect the undisturbed sample and disturbed sample. Means by making this process, it is a huge setup is there. You go and study them separately. So standard penetration gives some kind of n values. So higher the n values, higher will be the means better will be the quality of the soil. Lesser n value means poorer is the quality of the soil. So that much you remember. Next is laboratory test. So these are the field test actually. So after field test, we collect the sample from the standard penetration test and bring it to the laboratory. So after bringing it to the laboratory, we go for this kind of test. So first one is Atterberg limit, then California bearing ratio, that is CBR, direct shear test, expansion index test, hydraulic conductivity test, altimeter test, particle size analysis, R value test, soil compaction test, soil suction test, triaxial shear test, unconfined compressive test, water content, and specific gravity, and all these things are also there. Shrinkage limit. So these are the tests actually we go for. So you very importantly you try to remember the name. And finally this is optional actually. In many of the large projects, big kind of projects, actually we go for geophysical exploration also. So geophysical means it is a kind of non-destructive way, like in this earlier we have touched the soil, destruct the soil surface and dig out the soil from the bottom. But in geophysical we don't need to do anything. We just have some kind of high sophisticated machineries with us, and with that machinery हम लोग साइट पे जाते हैं और उसको हम यूज करके हम सॉइल का प्रॉपर्टी हम निकाल सकते हैं. लाइक ग्राउंड वाटर टेबल इन्वेस्टिगेशन, कितने में ग्राउंड वाटर टेबल लाई कर रहा है, तो हम विथ मशीनरी इटसेल्फ वी कैन डिटेक्ट. सिस्मिक वेव वेलोसिटी, surface wave analysis, electromagnetic radar, underground any kind of pipelines or any kind of means other pipelines are there or not. So this kind of things we can easily find out. So these are actually comes under geophysical exploration. So okay, so with this actually we have covered a few more important topics in relation to geotechnical engineering or soil mechanics. So please go through this lecture and try to solve the objective type of questions, and also refer some standard books and make the concept clear. Okay, so other remaining class I will try to cover the other related topics of the geotechnical engineering. Okay, thank you.